Okay, today I'll be talking about Gaia Black Hole 1. This is a newly discovered black hole that was recently found by the Gaia spacecraft. Um, and today I'll be talking a little about it. I apologize. I realized after doing a lot of research and halfway down the report that there's not too much known about it quite yet. So for this presentation, I've kind of had to, um, I'm going to go through the life cycle of like how a black hole is formed as well, just kind of add some content and go a little more in depth than we ever did in class. So hopefully that's good. Um, um, so like the basic life cycle of a star, a supernova is the violent end to a star, and a star that has 8 to 15 solar masses will end in a supernova, which could later result in a black hole. The life cycle of a star can be very difficult depending on the type of star and its mass. So once a protostar gains enough mass, its core gets hotter and denser, and then hydrogen can begin to fuse into helium and begin the process of nuclear fusion, which is how stars make their energy and how we get its warmth and light as well. Then it goes into a red supergiant. This is when it runs out of hydrogen to fuse, and then it starts to fuse helium, which increases the pressure inside its core, and it'll actually increase in radius and size. And then I think they theorize that when our sun goes into a red giant, it'll take up the radius of where Venus is now. So we'll be very close to like where Mercury is right now when our sun eventually does this. Um, but this will give it enough heat and energy to fuse helium into carbon, which, like I said, increases the pressure and expands the star. Now you get a red soup, um, and then when it runs out of helium to fuse, the core will contract again, and the mass of the core will increase. It will then become hot enough to fuse carbon and neon. So this process just kind of cycles when it runs out of its fuel source. And it will continue this process until its core is full of iron. And when this happens, it is no longer strong enough to withstand the force of gravity, and the star loses its battle. This is when a supernova occurs. At this point, the core temperature will begin to rise. It will reach a temperature of up to 100 billion degrees as the iron atoms are crushed together. And as the core shrinks more and more, the repulsive forces between the positively charged iron nuclei will overpower the force of gravity, resulting in a shock wave that starts from the core of the star. This results in one of the most powerful explosions in the universe. And then this brings up something interesting called the Chandrasekhar limit. This is a mass limit that will determine the fate of a star once it has gone supernova. So if the remains of a star has the remains of a star after supernova, so what's left of the core, has a solar mass less than 1.44, then it will turn into a neutron star. However, if it exceeds 1.44 solar masses, you are left with a black hole. The neutron star, if it doesn't turn into a black hole, it's usually the mass of 10 to 25 solar masses. And they're very, very small. So roughly 10 kilometers, which also makes them extremely dense. And its magnetic field is insanely strong and is about 100 billion times stronger than that of what we have here on Earth. So some crazy forces going on with a neutron star. And then, of course, you have the black hole. A black hole is a region of space-time where gravity is so strong that nothing, no particles or even electromagnetic radiation, such as light, can escape from it. And a regular black hole that is 3 times the sun's mass will have an event horizon of about 9 kilometers. That means it has a huge density of about 2 quadrillion grams per cubic centimeter, which is a lot. So the Gaia satellite is a satellite created by the European Space Agency and is tasked with creating a three-dimensional map of our observable universe. Um, Through the course of its mission, it will be able to observe incredibly accurate and acute data on positional and radial measurements of over 1 billion stars in our galaxy. And kind of how it does that is it uses reference points. So if the satellite or we are the observer here on Earth, it's going to map the universe by seeing subtle changes in stars, so it can gauge distances based on how fast something's moving or how slow something's moving. It can gauge that relative distance from here on Earth. So hopefully over time, as it accumulates more and more data, which I think it really has, it's already accumulated billions and billions of stellar mapping and binary star systems, like we'll talk about here in a second. But and hopefully we'll get a better picture of our observable universe and how it looks. Um, so this is Gaia Black Hole 1 is the newly discovered black hole that is now the closest black hole ever discovered from Earth, and it's 1,600 light years away, which is still really far. We'll still never get to it in our lifetime with our technology now, but it is significantly closer than the one that is in the center of our galaxy. And it is 9.62 solar masses, meaning it's about roughly 10 times larger, 10 times larger than our sun. And it was discovered using the Gaia satellite. What's interesting about this black hole, it has no mass transfer. So this was actually black hole found in a binary star system. So it has a companion star with the black hole, and our companion star is roughly the same size of the one we have here on the sun. So it's a main sequence star, much similar to our sun. And usually when you have a black hole that close to a sun, you have mass transfer, meaning the black hole is gaining energy or just sucking the energy and mass from the star slowly over time, which creates a X-ray burst with the black hole that usually we're able to observe. However, we weren't able to observe that here, meaning there's no transfer in mass, which is a rarer case. They think this might be due to the fact that it might be a tad smaller black hole than those we are discovering. But in any case, Gaia Black Hole 1 has shown no such event, so more research is being done on it, and hopefully they can figure out why soon. But like I said, unfortunately, there's not too much data they have on it quite yet, and I kind of learned that after researching it, but it's still really cool. And I hope you enjoyed.